constant temperature, volume, and pressure are inversely proportional. The units for this are volume in milliliters and pressure in ATM. As you can see here, the pressure goes up and the volume goes down, and vice versa. The equation for Boyle's law is P1V1 equals P2V2. A gaseous nitrogen sample in a 65 milliliter airbag has a pressure of 1.2 atm. If this sample is transferred into a 25 milliliter bag at same temperature, what is the pressure of the gas in a 25 milliliter bag? Let's start off with what we know. P1 equals 65 milliliters, V1 equals 1.2 atm, V2 equals 25 milliliters, and we do not know the value for P2. Let's plug in with what we know. 65 milliliters times 1.2 atm over 25 milliliters. And that calculates to 3.12 atm. A gaseous nitrogen sample in a 65 milliliter airbag has a pressure of 780 torr. If this sample is transferred into a 25 milliliter bag at the same temperature, what is the pressure of the gas in a 25 milliliter bag? Let's start off with what we know. P1 equals 65 milliliters, V1 equals 780 torr, V2 equals 25 milliliters, and we do not know the value for P2. Because we were given torr and not ATM, we have to convert to ATM. 780 torr times 1 ATM over 760 torr equals, the conversion rate between ATM and torr is 760 torr equals 1 ATM, so 1.03 ATM. Now plugging in what we know, 65 milliliters times 1.03 ATM over 25 milliliters equals 2.68 ATM.
Charles' law. At constant temperature, volume and temperature are directly proportional. The unit for volume is milliliters and the unit for temperature is Kelvin. As volume goes up, temperature goes up, but as volume goes down, temperature also goes down. The equation for Charles' law is V1 over T1 equals V2 over T2. If a 45 milliliter sample of gas at 226.5 Kelvin is heated to 255.2 Kelvin, what is the new volume of the gas sample at constant temperature? So let's start with what we know. V1 is 45 milliliters, T1 is 226.5 Kelvin, T2 is 255.2 Kelvin, and V2 is our unknown. Plugging in what we know and cross multiplying, we get 11,497.5 over 226.5x. And this was found to be 50.76 milliliters. If a 45 milliliter sample of gas at 23 Celsius is heated to 25 Celsius, what is the new volume of the gas sample at constant pressure? Notice that this is in Celsius instead of Kelvin. Our V1 is 45 milliliters, T1 is 23 Celsius, T2 is 25 Celsius, and V2 is our unknown. First, we have to convert the Celsius to Kelvin by adding 273. And we get 296 Kelvin and 298 Kelvin. Plugging in what we know after converting Celsius to Kelvin, we cross multiply 445 times 298, and that gives us 13,410. And 296 times x is 296x. And dividing those two numbers, V2 or x, equals 45.3 milliliters.
At constant pressure and temperature, volume and moles are direct proportional. The units that we use is volume in milliliters and moles in mole. As you can see here, when volume goes up, moles go up, and when volume goes down, moles go down. The equation for Avogadro's law is V1 over M1 equals V2 over M2. If 0.214 moles of argon gas occupies a volume of 652 milliliters at a particular temperature and pressure, what volume would 0.375 moles argon occupy under the same condition? Let's start off with what we know. V1 equals 652 milliliters, M1 equals 0.214 moles, M2 equals 0.375 moles, and we do not know the value of V2. We cross multiply 652 times 0.375, and that gives us 244.5 and 0.214 times x. If 0.214x, and dividing those two numbers, V2 or x equals 1,142.52. If 3.25 moles of argon gas occupies a volume of 5 liters at a particular temperature and pressure, what volume does 14.15 moles of argon occupy under the same conditions? V1 equals 5 liters, M1 equals 3.25 moles, M2 equals 14.15 moles, and we don't know the value for V2. Notice that we have liters instead of milliliters. Because of that, we have to convert. The conversions between those are 1 liter equals 1,000 milliliters, 5 times 1,000 equals 5,000 milliliters. Plugging in our results, we have to cross multiply 5,000 times 14.15, which equals 70,750, and then multiply 3.25 times x. Dividing those two numbers, x or V2 equals 21,769.23 milliliters.